12th is in a hypothetical Bohr's hydrogen atom. In hypothetical Bohr's hydrogen atom, mass of electron is doubled. Mass of electron is doubled. Energy E naught, radius R naught of the first orbit will be how much? If A naught is the Bohr's radius and minus 13.6 electron volt is energy of first Bohr's orbit. So we know that energy is for electron minus me raised to 4 8 epsilon naught square n square h square. So energy is directly proportional to mass. Mass is doubled. Therefore, energy will be doubled. That is, E naught will be minus of 27.2 electron. Radius in nth orbit is epsilon naught is epsilon naught n square h square upon pi me square. That means radius is inversely proportional to mass. Therefore, R naught will become half of A naught. Mass is doubled, radius will become half. So A naught by 2n minus 27.2 option. Sum number 12 we are doing from atoms, molecule, nuclei. Done?
Yes, sir.
Sum number 13. Series of hydrogen atom which lie in infrared region are. Say Lyman series, Balmer series, Bastian series, bracket series, Fund series. These are 5 series. Lyman series lies in ultraviolet. This is visible. This one is infrared. This is near infrared. This is far infrared. So series of which lies in infrared. Infrared is Bastian series, bracket series, Lyman and Balmer. So infrared, from this it is bracket series. Okay. 14th one. Which of the following transition of hydrogen atom gives absorption line largest frequency? When electron jumps from higher orbit to lower, then it gives emission spectrum. So this two reverse point, remember, when it jumps from high to low, then emission. If it rises from low to high, then absorption. So we want absorption or we want emission? What we want?
Absorption.
That means it should go from low to high. And in that absorption, frequency should be maximum, they are telling. That means difference between two orbits, energy must be maximum. So it can be 1 to 3 low to high, 2 to 3 sub low to high. 1 to 4 will be maximum because difference will be maximum between 1 to 4. So since difference is maximum between 1 and 4, therefore C is the option. It could be 4 to 1 if it is emitting, 1 to 4 because it is absorbing. Next, 15th. Wavelength of light emitted is minimum. Wavelength minimum, frequency is maximum. During the transition from emitted. Emitted means it should be from high to low. So 1 to 2 nahi chalega. 2 to 5 nahi chalega. 2 to 1. 2 to 1, 5 to 2. Out of this any one which is giving you minimum wavelength. If lambda is minimum, then frequency is maximum. So difference in energy should be maximum. Difference in energy is maximum between 2 to 1. So answer B, 2 to 1. 2 to 1 energy difference, if you remember, it is close to 10. Because first is 13.6, second is 3.4. Sixteenth. A monochromatic beam of light is absorbed by ground state hydrogen atom. A monochromatic beam of light is absorbed by ground state hydrogen atom. Ground state means first orbit. In such a way that six different wavelengths are observed when hydrogen relaxes back to the ground state. What is wavelength of this incident beam if R is 1.097 10 raised to 7? Okay. That means it absorbs and goes to some orbit. We don't know which orbit. But when it relaxes, it gives six different lines. Six lines it is given. Then we want what was that lambda or energy which it has absorbed. So whenever one line is obtained, then we have two orbits combined together. For one line, two orbits are together. This you follow what I'm saying? Two orbits are together. Meaning of this is it can jump between 5 and 4, 3 and 2, 2 and 1, but every time it will be taking two orbits into consideration. Followed? Hello?
Yes, sir.
So if it has gone to nth orbit, it combines two orbit at a time and gives six line. So it is called combination of two orbit at a time. Which orbit it has, how much I don't know. So NC2 is 6. This followed? Hello? This one is clear?
Yes, sir.
Now, if you can get n, that means you know the farthest orbit. Then I can find what is lambda by using Rydberg's constant formula. So from this you can say n into n minus 1 upon 1 into 2 is 6. This is how we solve. You start with n because it is 2, so we should write two terms. One is n, other is 1 less into upon 1 into 2. So n square minus n will be 12. So n square minus n minus 12 is 0. N minus 4, n plus 3 is 0. So n is 4 or n equal to minus 3. Orbit cannot be negated. That means atom has jumped to fourth orbit after taking that energy. Just copy till this first. We are interested in what was wavelength of that energy which was incident on that atom in the ground state. Done?
Yes, sir.
So we got idea that to emit sixth line, it has gone to fourth orbit. Now see what does it mean? If this is 4, 3, 2, 1. So fourth orbit to first orbit, 1 line, 2 line, 3 line, 4 line, 5 line, 6 line. But every time we cannot draw a line and check the orbit. So we should know formula total number of line is given by NC2. Now since 1 upon lambda is R into 1 upon n1 square minus 1 upon n2 square. So 1 upon lambda is R into 1 upon 1 square minus 1 upon 4 square. 1 upon lambda is R into 1 upon 1 minus 1 by 16. So R into 15 upon 16. Therefore lambda is 16 upon 15 R. So lambda is 16 upon 15, 1.097 into 10 raised to 7. Therefore, lambda is 16 upon 10 raised to minus 7 in meter. 15 sevens are 105, carry 10. 15 nines are 135 and 10, 145, carry 14. 15 zeros are 15 plus 14 will be 29, carry 2. 59 to 7. 15 to 0, 14, 0, and this will be 14. So 4, 6. So we are getting lambda equals to 16 upon 16.455 into 10 raised to minus 7 into 10 raised to plus 9 in nanometer. Meter to nanometer, we have to multiply by 10 raised to. Now this 16 upon 16.455 will be very close to zero point 0.1. That means close to 100. So if I take 16, it is 1 into 10 raised to 9. That is 100. So it is closest to 97 nanometer. Yes, done.
Yes, sir.
Okay, next one. H beta line of Balmer series has wavelength of. H beta line has wavelength. So lambda beta is 4860. Find the wavelength of H alpha means lambda alpha. For Balmer series, electron jumps from any higher orbit to second orbit. So N2 can be 3, 4, 5, dot, dot, dot. 3 to 2, then it is called alpha line. 4 to 2, it is called beta line. 5 to 2, it will be called as gamma line. So 1 upon lambda is R into 1 upon N1 square minus 1 upon N2 square. So 1 upon lambda alpha divided by 1 upon lambda beta will be, RR will get cancelled. 1 upon 2 square minus 1 upon 3 square. 1 upon 2 square minus 1 upon 4 square. So lambda beta upon lambda alpha equals to 1 by 4 minus 1 by 9, 1 by 4 minus 1 by 16. So lambda beta upon lambda alpha equals to 9 minus 4 is 5 upon 36 upon LCM will be 16. So it will be 4 minus 1. 3 by 16. So therefore, okay, please copy it in this. Lambda beta upon alpha 5 by 36 into 16 upon 3. 4 4 is 6. 4 9s are 36. 4 4s are 16. So lambda alpha will be 27 upon 20 of lambda.
Exactly 16. Exactly 7.
Yes, done?
Yes, sir.
The ratio of minimum to maximum wavelength of radiation that an electron in ground state can cause in host hydrogen atom. Ratio of minimum to maximum wavelength. In ground state means Lyman series. So we want minimum to maximum wavelength in ground state of hydrogen atom. That means in Lyman, that series is Lyman series. So here N1 is 1 and N2 can be 2, 3, dot, dot, dot up to infinity. Lambda will be minimum. Hello? Hello?
Yes, sir.
If frequency is maximum, wavelength will be minimum.
Yes.
For having frequency maximum, difference should be maximum. So last orbit to the first orbit will give you maximum difference in frequency. That means lambda will be minimum for last orbit. So lambda minimum is last orbit. This you have to keep in mind. Minimum is last. Lambda maximum is first orbit of that series. So I can say 1 upon lambda maximum will be R into 1 upon 1 square minus 1 upon 2 square because it is first orbit of Lyman series. And lambda minimum will be R into 1 upon 1 square minus 1 upon infinity square of Lyman series. So take ratio, it will be 1 upon lambda maximum upon lambda minimum equals to RR cancel. 1 upon 1 minus 1 by 4. This will be 1 upon 1 minus 1 by infinity is 0. So lambda minimum upon lambda maximum will be 1 minus 1 by 4 is 3 by 4 upon 1. 3 by 4. Just check 3 by 4 option. 3 by 4, yes, C option. Then this also.
Yes, sir.
If an electron in third orbit of hydrogen atom jumps to second orbit, then amount of energy released and wavelength of radiation will be. So E3 minus E2 is amount of energy released. Energy of third orbit is minus 1.51. Second orbit minus 3.4. So it becomes 1.51 plus 3.4. That means 3.4 minus 1.51. 10 minus 1, 9. 8. 2 minus 1, 1. 1.89 electron volt. And energy emitted is nothing but Hc by lambda. Therefore, energy is 1.89 electron volt. Hc I told you can write as divided by E to get answer in electron volt. This I told you remember shortcut. 12.43 into 10 raised to minus 7 upon lambda. So lambda will be 12.47 into 10 raised to minus 7 into 10 raised to 10 in meter upon 1.89. 1.89 is close to 6. So 6566 angstrom. This is one method. You could have also done 1 upon lambda is R into 1 upon N1, which is 2 square minus 1 upon 3 square. So if it recollects, this is nothing but first line in Balmer. Just now we got 6561 answer. So closest answer is that 6566. Done?
Yes, sir.
Check the correctness of following statement about Bohr's model of hydrogen atom. Check the correctness. First one, acceleration of electron in second orbit is greater than in first orbit. What is the relation between acceleration and number of orbit? A is v square upon r. V is inversely proportional to n and r is n square. So it is 1 upon n raised to 4. That means it is inverse. So this is wrong. A2 cannot be greater, it will be less. Orbit increases, acceleration decreases. Second part, angular momentum L2 is more than L1. L is NH upon 2 pi. So L is proportional to N. This is correct. Third one. Kinetic energy in second orbit is less than kinetic energy in first orbit. Velocity is inversely proportional to n. So V2 will be less than V1. Therefore, kinetic energy in second will be less than kinetic energy in first. Third is also correct one. So option 2 and 3 are correct. Option 2 and 3 are correct. If you are done, then please tell. You should have done this one?
Yes, sir.
Ah,
Yes, sir.
21. Energy E, magnitude of linear momentum of electron P, radius is R, quantum number means number of orbit n. Then according to Bohr's theory of hydrogen, which is true? First one is E P R proportional to 1 upon n square. E is proportional to 1 upon n square, P is proportional to n, and R is proportional to n square. That means this whole thing will be proportional to N. So first option is wrong. Second, ER. ER means proportional to 1 upon n square. N square. This is nothing but constant because this will get cancelled. So second is correct option. Next. 22. A particle of charge q, mass m, moving with constant speed v, perpendicular to the magnetic field v, then angular momentum about the circle, center of this circle is quantized so that mvr is nh upon 2 pi. Then the allowed radius orbit will be which one? See, whenever charge having mass m moves with velocity v perpendicular to the field, I think I have told again and again, then you should write q vb equal to mv square upon r. Are you remembering this? Hello?
Yes, sir.
So if I cancel this one v, then I get r as mv upon qv. Everywhere it is given r square equal to. So I'm just multiplying both sides by r so that my mvr can be replaced in terms of h. Now this becomes r square and mvr is nh upon 2 pi into qb. This answer. nh upon 2 pi qb. First option. Charge enters perpendicular. Always start with qvb equal to mv square by r.
Sir, done.
Okay.
Sir, done.
Yes, yes. Next one we are going 23rd. Redox constant R for hydrogen atom. Now this is, if you remember which quantity we substituted as redox constant, then it is done. Redox constant R is nothing but m e raised to 4 upon 8 epsilon naught square h cube into c. One more formula, remember. In nth orbit, we can write energy as minus rch upon n square. R means redox constant. So me raised to 4 upon 8 epsilon naught square h cube into c, where it is given h cube into c, 8 epsilon 0 square, I think B. Option 25th. So 25th. An electron in hydrogen atom first jumps from second excited state. This is ground state where n is 1. This is 2 called first excited state. This is n equals to 3 called second excited state. When it jumps from first excited state, second to first means third to second orbit, and then from first to ground, let the ratio of wavelength jumping from 3 to 2 to 2 to 1, momentum difference 3 to 2 and 2 to 1, and energy of photon from 3 to 2, 2 to 1 are A, B, C. Then we have to check what is the required ratio. B equals to 1 by C, they are telling. B equal to 1 by C, not possible, because this ratio will be 3 to 1. Then difference in angular momentum, see, angular momentum is nh upon 2 pi. L is nh upon 2 pi. So jumps from 3 to 2. Then it will become 3 minus 2, that is 2. 2 to 1, 3 minus 2, 1 and 1. So B is actually 1. So angular momentum energy cannot be equated. Wavelength and energy sometimes we can think. So first option is not correct. Then they are telling check whether B is A is 27 upon 5. A means ratio of the wavelength 1 upon lambda 3 to 2, 1 upon lambda 2 to 1 R into 1 upon 2 square minus 1 upon 3 square. This is 1 upon 1 square minus 1 upon 2 square. RR cancel. So this you can write 1 by 4 minus 1 by 9 divided by 1 upon 1 minus 1 by 4. So lambda 2 to 1 upon lambda 3 to 2 will become 9 minus 4, 5 upon 36 divided by 3 by 4. 4 nines are 36. So we get 5 upon 27. When you take reciprocal, then 3 to 2, 2 to 1 will become 27 upon 5. So A is 27 upon 5. Okay? Yes, that itself is correct. So B option is correct. Done? Hello, done? 24th?
Yes, sir.
25th. Okay. According to Bohr's theory of hydrogen atom, the product of binding energy in nth orbit and radius in nth orbit is. So binding energy is opposite of total energy. Product of these two is how much? So I know value in first orbit. We can say binding energy in first orbit into radius in first orbit. Because product, whether you take first orbit, second orbit, third orbit, fourth, all are same to same. Wrong? Hello? Yeah? No, I'm not interested. So binding energy in first orbit, it is 13.6 electron volt and radius is 0.53 angstrom unit. First orbit I have told, please by heart and be ready. Now 13.4, I'm taking approximately 14 into, this is 0.5 electron volt ampere. So it should be close to 7 electron volt ampere. Check. Close to 7, yes, D option. Twenty-sixth. Check the correctness of the following statement of hydrogen atom. First one, linear momentum in second orbit is more than in first orbit. Absolutely true. Kinetic energy in second orbit is more than kinetic energy in first. Wrong, because velocity is inversely proportional. Third, acceleration in second orbit is less than acceleration in first orbit. Acceleration is inversely proportional to 1 by 4, n by 4. So this is also correct. So statement 3 and 1 are correct. B is the option. Done?
Yes, sir.
Yes.
Okay. 27. Energy levels A, B, C. This line is called energy level. A, B, C of certain or atom corresponding to increasing value of energy are EA, EB, EC. A, B, C. If lambda 1, lambda 2, lambda 3 are wavelength of corresponding radiation, so C2A, when electron jumps, wavelength is given as lambda A. And B2A, first it is C2B lambda 1, C2B lambda 1, B2A lambda 2, and C2A lambda 3. Then what is correct relation? When electron jumps from C to B, then difference in energy is Hc upon lambda emitted. Same way from B to A, then it will become Hc upon lambda. And C to A will become Hc upon lambda 3. If we add this two, then we get Ec minus Ea. That is nothing but Ec minus Eb plus Eb minus Ea. So Hc upon lambda 3 is Hc upon lambda 1 plus Hc upon lambda 2. This will get cancelled. So 1 upon lambda 3 is 1 upon lambda 1 plus 1 upon lambda 2. Completed?
Yes, sir.
So first part of this chapter, atomic structure, we have completed. Next part is nuclei, that is